Another draft physics video presentation. Thanksgiving edition. What the hell? I'm so grateful to my audience and so grateful for this opportunity to speak to the human race and be able to interact, intelligently with all these great minds that exist. And no, I'm not really thankful. Yes, big mistake coming to Earth. I should have known better. It's so obviously a bad mistake that even in some fetal gestating form, I should have known. Don't do it, Gary. Don't do it. But anyway, somehow I got snookered into this slop. So, the Dermot O'Reilly guy has gotten back to me with completely nonsensical rubbish, and I just thought it would be a great illustration of this is what college professors, he was a professor, he did teach physics for some period, did other things, I don't know what they were exactly, a researcher of some kind I suspect, but whatever, just the attitude is just so amazing. So I offer money to prove me wrong. Okay, he won't take the money. He'll do it for free, but he won't prove me wrong. He won't demonstrate me wrong. He won't in any way argue me wrong. He'll just declare me wrong. Fine, great. That's the real scientist. You can see the real scientist in him just flowing out of him. This real wonderful scientific attitude of, don't tell me Jesus ain't God. He's the Lord of Lords. Who the hell are you to say he's not? It's just that bad. It's probably worse, really. I mean, I would expect religious people to be more humble, in their some recognition that maybe well, you just haven't felt God's love, some getting to the core of this, this faith argument. But he's overtly doing it, just overtly, obnoxiously saying it's not possible that you're right. I say so, and that's it. Anyway, I have bad news for you. Both the classical theory of diffraction, well, frankly, this isn't about light spreading. It's about a pattern created, and the single slit creates it. So I don't even know what the fuck diffraction has to do with this at all. The only thing diffraction has to do with it is scatter is diffraction, okay? So when you think diffraction only means when waves do it, well, what happens when a particle does it? Oh, yeah, well, you have to call that something. And frankly, it's spreading. So you want to say it's not diffraction, spreading, scatter, diffraction. They all kind of have to be the same thing, don't they? Oh yeah, they kind of do. But yeah, no, don't get the ABCs right here at all. You can't even line up ABC blocks with vocabulary that makes any sense. And you're going to tell me I'm wrong. Okay. Anyway, theory of diffraction. There's no theory of diffraction. And as I already pointed out, wave theory doesn't work. So again, you don't have a theory. All right, anyway, and quantum theory. So there's no theory of diffraction that explains the slit. So let's understand. There is none. There's just none. Okay? It's not, the wave spreading is not what's causing the pattern. If you see it in the single slit, it's not, you don't see it with water waves in the single slit. That's the whole point. So the whole point is that you can't call it diffraction. The pattern is interference. Professor Lewin, another college guy at MIT, maybe you should watch some of his videos, but he'll point out to you that there's no diffraction pattern. There's an interference pattern. But anyway, although not fully understood, well, that, I guess that's an admission of something. So you don't fully understand, but you're certainly sure as hell confident. Yeah, you've got no doubts that it's right, but you don't fully understand. Whatever. Exists on very strong footing. So the whole point of the video, the whole thing Feynman represents, Feynman is stating overtly, this is the whole thing right here. This is where it all starts. This is everything to this quantum theory. Okay, if this dies, yeah, a big piece of the argument dies. This is the argument. And I've pointed out how the argument is nonsensical, how it's not even close to being elementarily described correctly. It's fundamentally described with distortions and evasions and omissions and bullshit. Okay. They will not be replaced anytime soon. So you think they will be replaced sometime. So, but you just know it can't happen soon because we need what? Some sort of special thing to happen. For we have to reach four-dimensional intelligence to figure out the elemental function of a dumb, stupid universe. you know, Gravity. We're gonna have to wait till we get to the fifth dimension before we can understand. Oh, I mean, what a pathetic thing to say. It will not be replaced anytime soon. Like yours now, he does astrology and he can tell the future. He knows when soon is. It's not going to be real soon. It's going to be like soon, but kind of far away soon. Shit. Every man and his dog comes up with a failed alternative. So what? Yeah, there's lots of failed religions. And then there's evolution. And, so that's the thing, right? Is that intelligent people were able to look at Darwin's theory and add it up and say, yeah, it's a very good argument. Now, I didn't spend any time talking about how nonsensical their theory was, and I have spent some time pointing out how Feynman's just absolutely full of shit. Okay, that he doesn't understand any of this logic, right? He hasn't put any of these blocks together in the right order. So, I mean, yes, I'm spending time pointing out how this religious theory is stupid, but I'm also presenting you with a logical theory, scatter, that explains the phenomenon completely. I mean, it doesn't really miss anything. It's basically just arguing that in the two-source experiment, like with radar, you could just say, and in radio, you just say jamming. Jamming has the same math, it's the same mechanics. It works just as well as a theory. So why should I believe your extraordinary explanation of, well, the forces are interacting with the forces, even though we have no evidence forces ever do that, because they're superimposed and magically doubled. They have two identities, and they're on a VPN, and they're doing this and they're doing that, and so they're playing. They have two screen names, and they're having two different lives, and 15 different lives, or 496 different lives. And we're going to make a qubit someday that actually, you as a person, we're going to qubit people, and the people will actually be able to be 17 million different people all at the same time, and they're going to live 17 different lives, and then when they get to the end of their life, they'll be able to, oh yeah, I remember when I was, and I also was that, and I also was that, and I also was that. Yeah, because it'd be magical. It's so special, your theory. It's just so bad. So anyway, I've offered to pay him to show that I'm as dumb as a dog, but he won't do it. I'm willing to pay him to prove that, or demonstrate in some way, that I'm just failed stupid religion, that I just invented another stupid religion, that there's nothing distinctive, there's nothing that stands out in the sense that I haven't proven anything, I haven't demonstrated anything, and he won't do it. He'll do this though. He'll just shit talk me, because that's good science. Good scientists know they just have to shit talk any competing argument, right? So, there's, like I said, it's, the truth is that most of the theories of what it means to exist on Earth were wrong. Okay, for thousands of years, they had all kinds of wrong answers. But the truth was that smart people did figure it out. I mean, Darwin's grandfather was an evolutionist. He didn't need Darwin to find the proof because he already saw enough of it in the world. He already saw enough evidence that we can control selection, that we can breed animals into anything, we can turn them into anything. He already saw enough evidence to be convinced that there's something else going on here besides God poofing things. And he probably looked at our own anatomy and figured it out just from that. Why are we so fucked up? Nobody rational would sit there and build us this, they build a rhinoceros and build all these really kick-ass machines, and then it makes this silly fucking human thing. It's a joke, a bad joke on us. We're so underdeveloped, in terms of our efficiencies compared to something like the tiger. Anyway, I mean, the evidence was already there, and I'm saying the evidence is already screaming that this quantum wooey bullshit is just that, quantum wooey bullshit. Oh, I derived an equation. And it created a double triple singularity where 5 million tons of super energy is created out of bent space, and then the bent space turns into matter, and then the matter floats away and sings supercalifragilisticexpialidocious. I mean, your theory is so convoluted, such a pile of crap. Anyway, but that's what can I say? I mean, it's just so bad as a response, a scientific response. That is just so bad. That's just a religious person saying, "How can you deny the existence of Jeebus? The evidence is just so overwhelming that Jeebus walked the earth. All the water has his footprints in it. What about all that toast with Mary's picture on it? How did it get there?" I mean, he's a religious nut. All right. Teaching our children. The shame. Anyway. All right, so let's do some of this. So this is where I left off. And this part in the middle is a little boring, but anyway. And I really just want to get to this part where he draws it so badly. So just look at that really bad drawing, okay? Just look how horribly, awfully bad this is in terms of recognizing that even with bullets, the distance of these two humps is only going to be the distance of this, the separation. And the only part of this fringe argument is that only the fringes take new directions. All the light that stays straight, goes straight through the middle. All the bullets don't hit the surface, go straight. And they don't diverge, and they don't diffract. They don't spread anywhere. Okay, so if they're a foot apart, at the target, then they're a foot apart at the source, then they're a foot apart, so to speak, fundamentally at the target, no matter how far away it is. All right, and the whole point of having the screen at a distance, the whole point is to magnify, to make bigger the stuff that does have an angle of diffraction, that is spreading, that is scattered. The whole point of having a distance is to make those angles create a bigger and bigger difference that we can see. All right, so clearly these two lumps should be, it should be understood that if you're going to do this, make a comparison to photons or electrons, that these two lumps would be right next to each other, right on top of each other. That you're not creating two distinct patterns that are diffracted patterns, where the centers have moved, where they're going a new direction. No, the centers are still the centers. All right, they don't change. We don't need the arrow. Well, I'll leave it here. All right, and we'll draw a little. That's the thing to do. Put it back where it belongs, Gary. Come on, clean your room. World is just too ludicrous. All right. But I'll endeavor to persevere. I just keep doing. All I can do is be a right person. I can't help that you're all wrongies. Yeah, terrible wrongies. All right. So the simple argument is that slits are, this tiny distance. The whole experiment is 1 millimeter in light, right? And so at the meters away on the target, the stuff that goes, the straight lines from there would be so tiny, 1 millimeter. Okay, and the real pattern we're going to be watching is going to be, say, a foot, 1 foot. So we're amplifying a tiny little thing that happens here. If we put the screen here, the pattern would be so small, the whole pattern would be so tiny we couldn't see it. So the whole point of projecting it is to enlarge it. And so what we're looking for is the fringes, the things that have an angle, that are not leaving straight. The stuff not going straight. So if I was to have a 2-slit experiment and I blocked one of the slits, I would see this, And this is without anything scattering, right? This is the bullet example, so to speak. If I thought of photons as being just dumb bullets, okay, and not complex objects of any kind, that's what I would expect to see with one slit open. And if I close that slit and then open the other slit, that's, I'd see exactly the same thing. I mean, we're talking about a millimeter of difference in a foot. You're not going to see any of that. So they'd be on top of each other. Now the simple point is, again, that Feynman doesn't point out here when he switches to these other he's ruined particles by making them big bullets with no frequency and just no recognition that we're talking about some bullets that would be really, really tiny. All right? Really, really the smallest things in the universe. So he really cheats the bullet argument. But anyway, but both arguments are cheated in the sense that they don't even acknowledge that we already know this slit is going to create a pattern. So this single slit is going to create a pattern. All right, and we know the middle one's a little bigger, notch, 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 you could say, right? It's going to create a pattern. And this other single slit is going to create a pattern. And the two patterns are going to be essentially in the same place, just 1 millimeter off. So the second pattern is going to be here, you know. So if I have them both open, I would expect to see just this pattern. But the trick is, right, and there'd be a certain amount of light. So this is also the big, huge giveaway. There would be a certain amount of light. Let me do this. Should I do the center argument first? All right. We'll just do this argument first. So with one slit open, I'm expecting this. With the other slit open, I expect to see this. And then we get this more, a different pattern when both slits are open. And why is that happening? Well, one pattern, you get this. This one, you get this. That's one. So say the amount of light that hit here with one slit open, right? I have one slit blocked, one slit open, and I get one as the amount of light. We'll just call it one. And then when I have the other one closed and I open this one, I get 1. Well, the trick is when both of the open, I'm going to get 4. So right there, it's telling you, the experiment is screaming at you with 4 times as much light. So the point is that when you've brought in these extra, you have one slit open. What am I doing when I bring in the second one? Well, I'm creating, so I only have 2 sources, right? I have this source and I have this source. That's it. I just have 2 sources. When I open the second slit, what am I doing? I'm introducing 2 new sources, not just 1, 2. So I'm combining this line, and I'm combining this line. So it's really 4 times the potential to create a photon. So if they actually did this experiment where they measured how much light gets through with one slit, and then how much light gets through with the other slit, and then they measured what both slits are producing, they'd get this 4 number. And that's just a huge giveaway that, oh, okay, there were photons here that weren't being photons, right? That's the only way you can explain it. All you can say is that somehow adding these extra bits from over here made it possible to make photons here. From this, these sources became more powerful by adding stuff from here. So they only made photon, a certain number of photons were made. And now I'm going to make more photons by adding light. Well, they must have already been there, right? That could be the only rational argument is we're just not seeing them as photons. They're not in a condition to be called a photon. Now, they see exactly the same thing with the polarizing film, right? Exactly the same phenomenon in the sense that, they have the 2 filters the opposite way, and you get 0 light. Indicating that somehow this is blocking all this stuff going one way and this is blocking all this stuff going the other way, and so therefore you've killed the 180 degrees. One is killing everything going this way and everything's killing the other thing, everything going this way, blah, blah, blah. However you want to look at it. The point is so you have 0. And all I do is put another filter in, and I'm getting 25% or whatever back. So clearly, whatever was going through this filter, there had to be more, because I have to make the photons somehow. How do I make photons? By sticking a filter in. I can't make photons, so all I can do is change what's coming in, and what must be coming in is that 25% somehow is in there. I can't make the photons with the filter. So obviously the energy to make a photon was there, even though I'm not seeing it. I'm saying there's 10 photons. That's it. There's 10 photons here in this space. Well, obviously there's not 10, just 10 photons in that space, because all I do is stick another filter in and I get more photons out. So obviously there had to be more than 10 photons there. They had to be in a condition where they weren't quite photons, and now you made them photons. You just converted something that wasn't a photon into a photon. But the something had to be there. The energy had to be there. All right. So let's get back to the other argument about the double slit pattern. So as I've pointed out, this is really a simple equation. You just take the distance of the impediment, or the width of the slit, doesn't matter, and you're just basically counting how many wavelengths fit in there, and you're just projecting that on an equidistant. You're taking a distance from the screen and you're saying, okay, it's the same distance here, same distance here, okay. And so it's really illustrated by the fact that really you have two lines. You have the line from here and you have the line from here. Those are your two different length lines, and these are your notches. These are your wavelength differences. And you could just draw those wavelength differences right on this string here. You could put them on a string and just put it right on there. Now you just connect these two strings, okay? And now you just go and you say, where do I hit a notch? 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 And when I get to this top, what I'm going to have is two strings, okay? So I'm going to have a string from this surface and a string from this surface, and I'm going to have an equal number of notches on either side now. And the trick is, right, I just thought of this part of it that's so obvious, and I should have thought of it. So let's say I'm doing this math, okay, and so I have a distance and I have a wavelength. I'm just going to divide the distance, okay, and I'm just going to divide it by the wavelengths, and that'll give me an answer. Well, what if it gives me an answer of 15 even? Okay, so there's 15 even, exactly 15. What's this going to be? Right? Half of 15, right? 15 divided by 2 is 7. It's an odd number. That's sort of inconvenient, isn't it? I mean, how can I have a whole wavelength of difference? Right? That's what I'm looking for. 14 would be 7. Yeah, it's 7.5. Sorry, I'm saying which word I'm supposed to have something extra. Right? Half of 15, okay, is 7.5. 7.5 is saying, oh, that has to be an off node, right? That's destructive. Now, see, I'm saying there's no destructive. There's either rebuild a photon or don't. It clearly says out of phase. So even though these two strings are exactly the same length, the notches on the string are saying you're out of phase. And it's actually correct, because if you just move this a little bit over here, this will dramatically change these path length differences, because now you're making both strings in a sense, right? You're going from this center and you're moving this. Well, you can sort of just understand as the string rolls, you know the roll on the string can't lie, so you know the notches are telling you the truth, and they're screaming to you that no, you have to move over here. This is where the 8 is, right? So this is where the bright is, you know, where I have 8 notches on one side and 9 notches and 9 on the other. I have 8 on one side, making 15. So yeah, I should have made this a 6. Okay, no, I should have made this a 7. This is the even 7. So this is where the real bright is here, and the real bright on this side is over here. That's where the real ones are. That's where really the nodes are, and that's why you see that big center in the single slit, is because it's really 2 nodes with an interference pattern in the middle, and you're just using the laser light that goes straight through is just filling in the gap, so it looks like it's 1, but it's really 2. So again, it's not just about having a remainder, it's about having an odd number. So all the odd number, when you have an odd number of wavelengths that fit in there, you know you're going to be dark in the center, the real center. And the only center that's really giving you a bright is inside of this 1 millimeter. So we're back to this understanding. It's all happening inside of 1 millimeter. Only inside the very center of the 1 millimeter is there a bright. The real pattern is dark. Alright, so do I need to add anything else regarding anything new I realized? So the 4 times thing is important to understand, that you're really multiplying the number of sources when you add a second slit. So when I have a single slit and I'm making a dull pattern, this is a 1. When I add the second slit, there's 4 times as much light. There's 4 times as many photons. So the original pattern is still there. It's just that the new 4 times brighter pattern is on top of it. That's the one you're seeing. You're seeing the 4 time pattern. It's got the little bars in it because it's got the bigger distance. This big distance didn't show up till I added the second slit. The big distance is the one with lots of notches. That's the one creating the little bars. So the little bars were added by you introducing a second slit, because you introduced this big distance. This little distance you already had. this littler distance you're adding, so you're making the envelope bigger by if this distance is smaller than the opening. But traditionally they do it with this distance smaller than the impediment, because that's the only way they can cheat the math. So let's understand how they're cheating the math. They always say it has to be, oh, the slits have to be infinitesimally small. They say some kind of bullshit. Well, why are they saying that? Because if I make the slits really tiny, I eliminate the distance problem, right? Then I can just average. I could put a wave right here in the middle, and you wouldn't be able to tell the difference between the two waves on the right surfaces because it's less than a wavelength, right? By their own description. A wavelength or less. That's the rhetoric they use. Why would you make a slit that tiny? It's so tiny, it's incredibly small. And obviously nobody who wants to see a good pattern does that. But that's why they do it. It's because it eliminates the real mathematics. It makes it possible for you to average it and get it wrong. It makes it possible for you to say this center is the distance. Well, the difference between that center and these two real distances, the surfaces, will be so small, less than a wavelength, that it's not going to give you enough of a number difference in the bar pattern, so you'll be able to fudge it. You'll be able to say, well, the block is here. If I measure 6 centimeters down here, it's 6 centimeters. That means it has to be 500 nanometer light, and blah, blah. They can get a cheaty answer because they're using cheaty math. But if they use real size openings, their math completely fails. Because the real math is the surfaces. They're causing the phenomenon. It really is just scatter, and you really are taking a pattern moving through space, dot, 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 and you either have the pattern in phase or out of phase. When you send pieces, dots, to here, you either put them back together in phase, dot, 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 or you put them together in some wrong manner, dot, 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 which won't be a photon. It won't be able to be seen by the radio receiver, so to speak, the receiver of our eyes, the receiver of all the other chemical reactions. They can't see this. They need it to be a constant frequency. They need it to be resident to the electrons and the atoms of the material. And if it isn't at the right frequency, it won't be seen. Alright, that's probably enough of that. So we'll play a little bit of the Feynman thing just for fun and be done with this slop for the day. For today. Alright, get rid of that, and yeah.
Some hand, which is the number that arrive in this container per hour on the average, need not be an integer. It can be a tenth. Which would mean under those.
All right, so it's just, this is just where he starts to make jokes about 2.5 babies or something and blah 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 blah. So we already, all of you should be up to speed enough to know that you can count photons at positions, or you can put a piece of photographic film, or you can do lots of ways of detecting the pattern, and he's describing just one way to do it. All right, so we'll move ahead a little.
That is, what you get from the two holes open is the same as you get by simply adding each.
Right, so he says no interference, but we know, frankly, that there is interference in the single slit. And if he did allow the bullets to scatter, okay, and they had a frequency, that is, you shot them with a pattern going in, you could argue there's interference. So, it's just because he limited the particle model to not having any of the elements that are necessary for we already know it has to have a frequency. So he didn't include frequency anywhere in the particle example. So he's cheated it so badly that it doesn't have any chance of fitting the evidence, because he didn't give it any chance to fit the evidence.
Hole settled. That's for bullets done. We're done with bullets. All right, I begin again. This time with water waves. Here is standing some kind of a big mass of stuff which is being shaken up and down.
So let's understand that 15 years later he said it's not waves. Clearly. Waves don't do that. That's how you describe it. His theory is that there's a random God. That it is just random. That's it. It goes in and magic happens and it comes out wrong. But it's not because it's a wave.
This is a long line of barges or jetties with a gap in the water in between. Perhaps it's better to do with ripples than it is to do with big ocean waves.
So again, that is so totally superfluous to the argument. You don't need this gap here because that's just going to create round waves, we know. So it isn't a very good theory. But if you have a long enough distance, the round waves start to get flatter and flatter. You can sort of understand if you're really close to a pebble when it's put in the water, the waves seem very round. But the further away you get, they get bigger and bigger. And as the circumference gets big, like the Earth, the circumference gets big enough, some idiots could look at it and say it's flat. But it's only because the Earth is a certain size, right? If the Earth was twice as small, then we wouldn't have flat earthers because they'd be out of luck because we'd all be able to see that it's not flat.
More sensible. Wiggle my finger up and down here, and I have a little piece of wood here, and ripples start out here, and then I've arranged in a tank to put boards in the way here, so that I have these two holes, and then I have this so-called detector, and then what I do with the detector, what the detector detects is how much the water is jiggling. For instance, I put a cork...
So it's different than light in the sense that you're taking a place that's going on, off, on, off, on, off. The light's flickering on, and off, and then there's a place where it's just going, it's dull. So that's the difference in the pattern detection. You're detecting on and off in one place, rather than like in the photon example where it's bright and dark.
In the water, and measure how it moves up and down. And what I'm going to measure, in fact, is the energy.
Jump ahead.
It doesn't come in lumps. It's not all there or nothing. And what we're going to measure...
So he's just pointing out that waves can vary in how much they jiggle.
Which, to be precise if you want, is the energy generated by the waves at a point. And now what happens if we measure the intensity, which I'll draw on a third curve here, which I'll call I to remind you it's an intensity and not a number of particles of any kind, and I12 when both holes are open is a curve that looks something like this.
So, he started it off way wrong just because he's ignoring the big maxima. You have to put it in the middle, the double one. So a fundamental feature of the single slit he threw away. I mean, it's fundamental.
An interesting, complicated looking curve, which ought to be symmetrical. It didn't do too badly, actually.
See, it ought not to be symmetrical, actually. The center should be twice as big. Again, something they don't explain. But I mean, it's just missing key features are gone from this, right? One slit's open, it's a big center. The other slit open, big center, right? And they're 1 millimeter apart. They're on top of each other and just off by 1 millimeter. But that's not going to be explained either.
Very complicated looking curve. That is, if we put the thing in different places, we get a very, very different intensity, which varies very rapidly in a peculiar manner. And you're probably all familiar with the reason for that. The reason is that the ripples, as they come out of here, have crests and troughs spreading from here.
All right, so let's understand this fails entirely. So Dermot O'Reilly, the physics professor, will assert that somehow this isn't failed physics, that this whole drawing isn't completely bad and misleading and wrong. The two waves coming out of the two slits, when Young drew it 200 years ago, was wrong. It's still wrong. More than 200. So, I mean, it's just wrong. It won't give you the right answer. If you put the little dot in the center, let me use my little arrow. If I put a dot in the, that was the wrong one. That's not what I wanted to move. I don't know what that was, but it's a good thing I don't need it too much. Whatever it is, I don't need it too much. If I put the dot right in the center of the opening, and then the dot right in the center of the opening to identify the center of the wave, that math will not work. It won't get anything right. It can only work if I make the slits so tiny that it becomes mathematically irrelevant. Like it's like the margin of error can consume how much you'll be off. It's still off. It's just less obviously off. Let's just put it that way. If somebody did the experiment carefully, they could still see that it's wrong. Okay, but it's harder to see that it's wrong just because the amount it's off is so tiny. But clearly, the bigger I make those openings, the more obvious it's wrong. It gets more and more obvious how profoundly wrong it is the bigger I make those slits. So it's mathematical rubbish, absolute garbage, can't work, doesn't work, doesn't create the pattern, and they keep telling me they're on a strong footing. A strong footing of failed mathematics. Maybe a dog. Maybe I should try to see if I could teach a dog the difference between the center and the surface. Because I think a dog could probably figure it out. He probably knows not to piss on the center thing, right? He finds the surface to piss on. So even a dog could figure out where he should be pissing.
And they have crests and troughs running from here. Now, if we're at a place which, say, is exactly in between these two things, so that the two waves arrive at the same time, the crests will come on top of each other, and there'll be plenty of jiggling.
Right, and so that very point again, as I just pointed out, doesn't work. It's the wrong starting place. The right starting place is 90 degrees away from the slits, where there you have the full path length difference, and there you'll know what the node is and reliably, and the rest of them have to be proportional to those starting places. So you're doomed. The fact is that if there's a certain number of wavelengths, you're just not going to get the light to be in phase at that center maxima. Most of the diffracted light won't be in phase there if you have an odd number of wavelengths in the distance. Fact.
It's the exact opposite of this curve. So I'll have to put, there should be another bump. You have a lot.
So understand, there should be another bump. Okay, we're just doing this casual thing for morons. I won't point out the actual pattern has actual features that demonstrate how this theory doesn't work and can't work, and it isn't the right math. And again, so it's all just propaganda. This is just talking about, fake dinosaur bones or something. I mean, this is, they found some pieces of wood on Mount Ararat or whatever. An astronaut went and found it for us. So therefore, there must be a God, because they found a piece of wood on top of a mountain.
A lot of jiggling right in dead center.
And, they found that shroud thing that's, Jesus was 11 feet tall. So what? So they didn't mention anywhere in the Bible that Jesus was a preposterous giant. That's okay.
On the other hand, if I were to move to some point here, since I'm further from hole 2 than hole 1, it takes a little longer for the waves to come from 2 than from 1. And when 1 has a crest arriving, the crest hasn't quite reached there yet from 2. In fact, it's a trough from 2.
Right, so we're just back to the phase difference, which is the argument, yes. Both theories, particles and waves, would say, yes, there's a phase. So if I have bullets traveling longer distances, that is, I shoot bullets in a pattern, bang, 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 into the slits. We know that, one bullet goes this way, one bullet goes that way, one bullet goes that way. Well, then I have a whole bunch of other people start shooting the bullets too. Then we know that my bullet that goes this way can match up with his bullet that goes that way, and they can end up going 1, 2, 3, bang, bang, bang. I'll just repeat the same pattern. And the odds are I only got 2 choices. I either repeat the pattern or I don't repeat the pattern. I mean, it's that simple. I mean, it's 50-50. If I wanted to try to get completely out of phase or completely in phase, I'm going to have a 50-50 chance at every location of being one of those two, and just expanding them just as the same rules apply. So I can be a lot off phase or a little off phase, and that's really all you're saying, and it's a 50-50 chance.
So the water tries to move up and it tries to move down from the influences of the waves coming from the 2 holes, and the net result is it doesn't move at all, or practically not at all, and so we have these low bumps at that place. And then if you move still further over, you get enough delay that when a crest is here, this other crest is in fact one whole wave behind. So
it's way behind, so it doesn't arrive at the same time. It doesn't do any of that kind of stuff. It's a frequency. So again, their wave theory, they're allowed to have time. A photon is an event that happens over time in wave theory, but somehow in particle theory it doesn't take any time. There's no time for the frequency to manifest in their particle analogy. So it's such an unfair description. You're going to make a comparison and you don't have the same rules at all. The wave is allowed to have wavelets, continuous waves. The particles aren't allowed to have continuous particles. It's just such a cheat.
In fact, it's a crest the 2 crests are coming on top of each other, but not the same crest, so to speak. The 4th crest from here and the 5th crest from there on top.
Yeah, so exactly, right? So exactly, stuff that arrived later and stuff that arrived sooner. So clearly this is about stuff arriving at the two slits at different times, creating something, okay, remaking the pattern.
A big one again and a small one, a big one, small one, depending upon the way the crests and troughs interfere, as we say. The word interference, again, is used in science in a funny way.
Yes, it's very funny. Obviously this idea that there's constructive and destructive, noting, again, there is no destruction. The polarization film experiments kind of prove the photon isn't destroyed, it's just made unrecognizable. You break the phase, you don't ruin the energy. So if I have two radio signals hitting me and they're out of phase and I can't receive either one, it doesn't mean the energy's not hitting me. It doesn't mean that my atoms aren't getting vibrated. All that stuff's still happening. I just can't tune it in. That's the simple answer.
Because we'll have what we call constructive interference. When they both interfere here, it makes it stronger. Well, they call it interference anyway.
So well, yeah, it sounds a little stupid. Yeah, I don't get it. Whatever. Let's just move on.
But the very important thing is that I12 is not the same as I1 plus I2, and we say it shows interference. Yes, interference.
So obviously it's not even in a more dramatic way, because he's not even conceding that with both slits open there's 4 times as much light. So, obviously they don't equal each other.
That's the funny term we use, constructive and destructive interference. I didn't mention what I1 and I2 look like, but we can find out by closing this, for instance, to find I1. The intention is to get here, if the hole is closed, is simply the wave from one hole for which there's no interference, and that's...
All right, so he says the wave from one hole, but we know in photons one hole does create interference. So again, this is the big part of the big lie. It just makes a lump. No, it doesn't just make a lump. It's a pattern.
This curve, N1, is the same as I1, and the same way otherwise I2.
And again, he's got them drawn preposterously distant from each other, so as soon as you made this analogous to the small slit distances of light, this doesn't make any sense, because those two images will be right next to each other. I mean, so close you wouldn't be able to tell.
And this curve is quite different than the sum of these two. As a matter of fact,
well, and again, the sum of those two aren't the real pattern. So again, you've just totally denied. So there would be a great deal of similarity if they did it honestly, right? They drew these two, well, if they drew these two lumps, okay, right next to each other, right on top of each other essentially, and then they drew them with actual bars, because that's what they actually would do. The single slit produces lots of pattern. Then you could say, well, now all I change when I have two slits is I'm changing where these bright and dark spots are, in the sense that what I'm not changing whole locations that were light and dark, I'm just making it even more specific. There's little brights now, and that's going to be the only difference. The real difference is going to be you're going to have brighter brights in some locations, new brights, smaller brights that are going to represent the longer distances putting two slits created. The longer path length, the extra slits create the opportunity to reconstruct a photon with. Just such a fraud. Very bad science.
Mathematics of this curve is rather an interesting one. What is true is this, that the height of the water when both holes are open is equal to the height that you would get from number 1 open plus the height that you get from number 2 open. Thus,
see, that's where you just failed again. They never measured it, they never did any of this stuff, right? Because photons, it's not going to be true. It's going to be 4 times.
If it's a trough, the height from 2 is negative and cancels out the height from 1. So you can represent it by talking about the height of the water. But it turns out that the intensity in any case, for instance when both holes are open, is not the same as the height, but it's proportional to the square of the height. And it's because of this fact that we're dealing with the squares that we get these very interesting curves. All right, now, you erase the machinery.
That part, he's just using a gimmick to pretend that it is, 4 times, in the sense that the square, well, it wouldn't be 4 times, it would be, whatever, the square of it. And And he's just using the fact that he's just saying, well, the low is the, he's saying the thing is swinging two directions. Like it has a plus and then a minus component. And, light doesn't have that. Yeah. So he's taking the biggest distance between the lowest low and the highest high and saying that's the representation of the actual energy when it really isn't.
And start over. This time we start with electrons. We have a filament here, tungsten plate, holes in the tungsten plate, and for a detector, any electrical system which is sufficiently sensitive to pick up the charge.
All right, let's just understand this. The experiment isn't done this way. So again, it's just another lie. So instead of sticking to photons, which are actually done that way, he changed it to electrons just to make everything the same again, and just to, again, pervert the presentation of the evidence. The electron experiment is not that simple. And if it were, then it would be a convincing experiment, but it's not. And that's just a simple truth. There's a bunch of manipulation of the electrons before it even gets to the slits. And then there's a bunch of manipulation of it after it goes through the slits. So again, not the same experiment at all. Lots more parts, lots more stuff in the experiment. 4 times as much stuff as he drew there.
An electron arriving with whatever energy the source has. Or if you would prefer, we could use photons. And
there we go. Yes, I would prefer. That's what I would prefer, but that's not what you do. You just keep switching to electrons.
The black paper with a hole in it, 2 holes in another sheet of black paper. Paper isn't very good because the fibers don't make a sharp hole, so we use something better. And here, for a detector, a photomultiplier that can detect the individual photons arriving. Now what happens?
Why don't we just look at the screen with photons, right? We don't need the detector, right? We can just look at the screen and see where the photons are.
With either case, and I'll discuss only the electron case, the other case is exactly the same.
So again, he says it's exactly the same. It's really not exactly the same. So no point in saying it. It's not the truth. Blah blah blah. And if he stuck to electrons, the like I said, the obvious distortions here would be obvious.
Photon is this first. Now what we receive in this electrical detector, with a sufficiently powerful amplifier behind it, are clicks. Click, 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 click.
Right, which would tell you that you have a click detector, right? That your detector is telling you it has to come in a clump, or I can't see it. It has to have the right frequency, or I can't see it. It has to have enough little bits in it, or I can't see it. The clump detector is basically saying to you, even if you have a wave theory, if there's not enough waves coming, if only one wave hits, no click. Okay, if the waves are in the wrong sequence, they're too close together, one is far apart, no click. That's what it's telling you. It's telling you that I can only see certain patterns, and any other pattern, it doesn't matter that it's a real thing, it's not a real thing to me. I'm not going to click. So it's a clump detector. The detector is telling you it has to be in a certain condition or I don't see it. It's not detecting the essence. It's not detecting the element of a photon. It's detecting a very specific thing. You have to have the right key code or you don't get in the door. That kind of thing. Doesn't mean you didn't press buttons. Because you didn't press the right code doesn't mean you didn't press the buttons.
So on with the source here. Lumps. Absolutely lumps. When the click comes at a certain size, and the size is the same, you can turn the source weak.
So look, my simple argument is that you could put your clump detector where the dark spots are, and if it wasn't a clump detector, if it didn't have a key code and just measured pressing the buttons, lots of buttons are being pressed. So there's buttons being pressed in all the locations. There's energy hitting all the locations. It's just only certain locations is the energy the right code. The other locations, it's not the right code, so our code detector can't see it. But it's still energy. It still hit the surface. It still moved electrons. It still did stuff. It didn't do the same stuff, and that's all that matters. It didn't tip the electrons. All right. Simple explanation. All right, so that's probably enough for today. And we'll play some more the next time. We'll do another shot at this whenever it's convenient, I suppose. Just because it's just a clear illustration of how bad their science is, and university professors will say this is a strong footing. This is a solid argument. We've really done something here in our explanation of the physical reality and explaining it to people. When it's a terrible generalization, terrible perversion, terrible distortion of the actual physical facts. It's just propaganda. And you people seem to want that, I guess. I don't know. That seems to be something that compels you. You know, it's just such, like I said, the planet of the idiots. It's just sad. You really are all a bunch of idiots. Sad. Sad for me. You know, not being an idiot. Anyway, till the next time and such. So forth and whatnot.